Good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I'm making another video, and my last video I made it to analyze and forecast on Bitcoin using an RNN, which is a recurrent neural network. But in this video, we're going to talk about how to predict on and analyze Bitcoin using a CNN, which is a convolutional neural network. So because I'm using a free screen recorder, I can't move around from tab to tab. So I'm just going to tell you what I got off the internet about a CNN. A convolutional neural network, or CNN, is a type of deep learning neural network architecture commonly used in computer vision. CNNs consist of multiple layers, such as the input layer, convolutional layer, pooling layer, and fully connected layers. The convolutional layer applies filters to the input image to extract features. The pooling layer downsamples the image to reduce computation, and the fully connected layer makes the final prediction. The network learns the optimal filters through backpropagation and gradient descent. Although traditionally developed for 2D image data, CNNs can be used to model univariate time series forecasting problems. So that's what we're going to be doing. Univariate time series are data sets of a single series of observations with a temporal ordering, and a model is required to learn from the series of past observations to predict the next value in the sequence. So that's basically what a CNN is and does, and how it can be used for time series. And I'm just going to take this out because this was for an RNN. So I'm just going to delete that. And also what a time series is and how to use it. I will say that whenever I did the RNN, which you may or may not have seen, somebody messaged me asking if I can make the program where you can predict on future unseen data. Well, I would be able to do that. I could do that. But the thing is it's really easy. It's not that difficult to do, and I could do that. But I thought about it, and I thought, well, if I make a video on how to predict on future unseen data, if the forecast wasn't correct, then the person that asked for that information, in theory, could sue me because the forecast wasn't correct. And, this is all a science. And so I told my friend that, who has legal training, and he said, oh, well, you can just put without prejudice in your sentences. But I thought about it, and I could do it easily, but I'm not going to do it because I don't want to show someone how to do it and then to make predictions on Bitcoin and have the Bitcoin not have not have the actual values what the predictions were, and then you're going to turn around and they could turn around and sue me for that. So I'm not going to get involved in all that stuff. And I know what they wanted. They wanted to be able to buy Bitcoins, and they wanted to be able to determine the best time to actually buy a Bitcoin. So I know what they were doing. And the only thing that I can suggest is they learn how to do it themselves, because I'm not going to put myself in a position where I could get sued. And then so we made our program. Program is the same as the program that we had using the RNN, which is a recurrent neural network. The only difference is I used a CNN instead of an RNN, and that was the only difference. So whenever I made the program, I did it in Google Colab. So the first thing that you want to do is you want to import the libraries, which are Pandas, NumPy, DateTime, Math, sklearn, Matplotlib, and Seaborn. And then later on down in the program, when we get to the deep learning part of it, then we will import Keras and TensorFlow. So we're going to read the file, and basically I got the file off of a Bitcoin website, and then I had to download it, and then when I downloaded it, I had to upload it into my Google Drive, which was hard because it downloaded, it was like a G sheet, and you don't want a G sheet, you want a CSV file. So it was a bit difficult for me to convert it to a CSV file, but I did. And then so whenever we took the CSV file and we converted it to a data frame, you had to start, end, open, high, low, close, volume, and market capitalization. And so we check the info. You can see that the first two columns are objects and the rest of the columns are numeric. We checked for empty values, and we didn't have any empty values, which is good because I didn't have anything to impute. But if you did need to impute values, you would have to impute them using pandas for a time series. Then what I did was I used date time to timestamp the end, because your end is going to be what we're going to be using. That's going to be your close of business, what we're going to be using. So we timestamp the end. And then after we've done that, then what we do is we set up our features, which are end and close, and we create a new data frame using closing BTC, where you have your end and your close. And so what we do is we use Matplotlib to plot the closing price along the date, and so you can see what the closing price is along the date. And then what I did was I used Seaborns to create a histogram of all of the prices, so you can see that. We use Matplotlib again to plot the date for 2023, so you can see what the prices looked like from January to December 2023. And then now what we're going to plot, use Matplotlib to plot October to December 2023. So you can see what it looked like October to December. So now what we're going to do is we're going to do a seasonal decompose on this time series data using stats models, and we're going to use multiplicative decomposition and additive decomposition. So first thing we look at is multiplicative decompose, and you can see the trend, the seasonal, and the residual. And then after we've done the multiplicative, we'll do the additive decompose, where you can see the trend, the seasonal, and the residual. So if you're really into statistics and you want to use statistics to analyze the time series, then you can use stats models to do that. So now what we're going to do is we're going to do feature extraction. So we're going to get the year, month, day, day of week, and week name from the end. And then we're going to put that into features. And then so when we put it into features, then we create a data frame. And you can see when we've created the data frame, you can see that's what it looks like. So we made a bunch of box plots. This is for the month. So you can see what the traffic is for every month. And then you can see the years, check the traffic for each year, and you can see 2024 has the most traffic and 2023 has the least traffic. And now we check the traffic for the day of the week, and you can see it's pretty similar every day of the week. And then now we're gonna resample it. And this is going to be the end of the year. So you're going to resample the end of the year. So you can see what it looks like, the traffic looks like at the end of the year. And then we're going to resample at the beginning of the year. So you can see what the traffic looks like at the beginning of the year. And then now we're going to do monthly resampling. So you can check the mean of every month for 4 years, for 2021 to 2024. So I think that's 3 years. And then now we're going to do rolling again, so you can see what the rolling time series is opposed to the regular time series. And I couldn't have a window of 0. It wouldn't work with a window of 0, so I had to use it with a window of 1. Now we're going to use the deep learning part of this program. So we're going to create a new data frame called ML features. It's going to be end and close. And then after we've done that, we're going to reverse the data frame. And then, because what we need is we need the end to be the most recent date, and the end of the data frame to be the most recent date, and the beginning of the data frame to be the farthest away date, the date that's oldest date. So now what we're going to do is we're going to set up the training set. So the length of the training set is going to be 80% of MLBTC, and then we're going to split this data set into training and validation data. So training data is going to be 80% of the data set, and validation data is going to be 20% of the data set. So we just check val data so you can see what it is. So you can see that the earliest date is at the beginning and the most recent date is at the end, and that's what you want. That's what you want to see. So now what we're going to do is we're going to scale the train set and the validation set. We're going to scale that with using sklearn's min-max scaler. And then what we're going to do is we're going to define our X train and our Y train, because you have to make the time series to be a supervised learning. And then now we're going to set up our validation set, our X val and our Y val. And then after we've done that, we're going to reshape the X train and Y train, because you're going to put 50 in there. And you're going to reshape your X val and your Y val as well. And it's going to have 50 in it as well. So now what we're going to do is we're going to import our TensorFlow libraries. So we're going to import TensorFlow, and we're going to import Keras, and we're also going to import sklearn. So your Keras is actually part of TensorFlow. So I set my seed to 42 just to make sure that you get the same answer, or pretty much the same answer every time. Now we've defined our model, and in this instance we're going to have a convolutional neural network, and the model is going to be sequential. The first layer is going to be your input layer, and it's going to be a convolutional 1D. And then you're going to have your max pooling layer, and you're going to flatten it. You're going to have a dense layer of 50 inputs, and then it's going to go into a dense layer of 1 output. And then we're going to compile it. with an Atom compiler and MSC loss. We're going to train the data into the model. And so we trained it for 20 epochs. We could have trained it for more epochs, which may have given us a better reading. And then now what we've done is we've used, I think it's pandas, to plot the noise. And you can see that the noise has gradually decreased with each epoch. Now what we're going to do is we're going to predict on the validation set. And so there's your prediction on your validation set. And then we're going to reverse scale the prediction. We're going to reverse scale Y-val, because remember at the beginning of the program you scaled it. So now we have to reverse scale it. And then we're going to reverse scale the prediction. And then after we've done that, we check our noise, our error, which is 2118, which is slightly better than it was using a RNN. And then we're going to create a data frame that has the actual and predicted values, so you can compare the predicted values with the actual values. Now we use Matplotlib to plot the actual values against the prediction. So you can see that it looks pretty good. And we're also going to use Matplotlib again to plot the prediction against the actual values in a time series. And then so you can see that as well. So you can see that the prediction is very close to the actual value. So that's what you want to see. Now this person that asked me to make it so that where you can predict unseen data, the way you would do it is that you wouldn't split the data frame up into X train, X val. It would just all be X train. And then you would create a new data set that had the dates that you wanted later on, like maybe 30 days or 60 days. And then you would just make a new data frame that, see if I can find it, that had the end as the dates that you wanted, being either 30 days or 60 days, and the close wouldn't have anything in it. You could say close is 0 or close is 1. The close wouldn't have anything on it because you're predicting on unseen dates. And then that's how you would do it. And then you would like maybe call that X test. And then so whenever you made your prediction, you would say, you would come over here when you made your prediction, rather than predicting on an X val, you would predict on an X test. And then so you wouldn't have any actual values because you were predicting on unseen data. And that is how you can do it. But I'm not sure that I'm going to make a video telling people how to do that, because the thing is people who are going to be interested in this sort of thing probably are going to be looking to buy Bitcoin. And let's say that the predictions are not in the way it was in real life, then they could come back and say, well, you showed me how to do this and you didn't do it right, and I'm suing you. So I'm not going to get involved. I'm just not going to get involved in all that. I know how to do it, but I'm not going to make a video showing people how to do it, because for my own, not wanting to get sued. So that's the end of this video. If you like it, please like and subscribe. Thank you for subscribing to my channel. Thank you for supporting my channel. And I look forward to making more videos for you in the future.